In this video, I'm going to show you how to integrate x inverse sine x. So to do this, we need to combine integration by parts and trigonometric substitution. So let this be v prime and let this be u. So v would be x squared over 2, and u prime would be 1 over root 1 minus x squared. So I'm expecting you to be able to differentiate this. So now use integration by parts. So it would be equal to u times v. So that would be x squared over 2 times that thing there, inverse sine x. And then minus the integral u prime times v. So that will be x squared over 2 times u prime. So that would be this thing here, 1 over root 1 minus x squared dx. Okay, so now we can clean this up. Factor out the half. So that would be, hang on, let me carry this thing down, inverse sine x, and then drag out the half and then multiply the two fractions together. So that would be minus a half integral x squared over root 1 minus x squared dx. So now use trigonometric substitution. So create a right angle triangle in such a way that this thing here will be true. So let me just create my right angle triangle. This angle is theta. If we remember, your eyes should zoom into this square root thing. So let's make this to be x, to be 1, and this to be x. So using Pythagoras, this will have no choice but to be root 1 minus x squared. So this is us using Pythagoras. So now we need to extract dx. So this is your sine. This is your sine theta. So this is sine. So that would be sine the angle equals x over 1, which is just x. So now that would then become, take the differential of both sides. So that would be differentiate it. That would be cos theta d theta. This will be dx. And this square root thing is really cos. So if you look at this triangle, cos the angle equals that square root thing over 1. So it will be root 1 minus x squared. So now we can substitute everything. So let me just carry this thing down. X squared over 2 inverse sine of x minus 1 over 2. And now we can substitute x squared. So if you look at this, x is this, so you square both sides, so that would be sine squared theta over, and then that square root thing here is cos theta, and that dx thing is this thing here. So that would be cos theta d theta. So now we substitute everything. So now these two will cancel each other out, giving you sine squared theta. So that thing there will then become sine squared theta. So that will then become sine squared theta d theta. So to integrate sine squared, remember it's kind of difficult, so we will always jump to this thing here. So that's the same as u. Hang on, let me clean this up. Hang on. So to integrate this sine squared, we would use this. I'm expecting you to know this. So that would then become x squared over 2 inverse sine of x minus a half, and then integrate this thing here, I'm just going to split it up. So I'm going to rewrite it like this: minus minus a half cos 2x, 2 theta in our case, 2 theta d theta. So now now we can, this is easy to integrate, this is easy to integrate. So this would then become x squared over 2 inverse sine x minus a half, and then bracket. Okay, when you integrate this, it would be a half theta minus, when you integrate this, your eyes zoom into this bit here, and so it's if you integrate this, it would be something of this form here. If you were, well, integrate this, I'm expecting you to know how to integrate this. It turns out to be a quarter sine 2 theta. Yep. So I'm expecting you to know how to integrate this. We've done this many times. So that would then give us this thing here, and then let's multiply this out. So this times this times this. That would then become x squared over 2 inverse sine x. This times this will be minus theta over 4. Theta over 4, and then this times this will be plus 1 over 8 sine 2 theta times 2 theta. And then now let me think. Oh yeah, this block here, whenever you see sine 2 theta, you can replace it with sine block, cos block. So that would then become x squared over 2 inverse x minus theta over 4 plus 1 over 8, and then replace this with this. So that would be a 2, and then sine x, sine theta cos theta. Remember, we don't want the answer. We don't want the answer in terms of theta. So we would replace this sine block as x. So you would, from here, you would go back to the diagram. You can see that sine theta is x. So this block here is x. And then the cos block is this square root thing. So that would be square root 1 minus x squared. And then what is theta? You would go back to here. Theta is inverse sine of x. So this thing here would be inverse sine of x. And then 2 over 8 is 1 over 4. 1 over 4. So this is your final answer, plus c, the constant. So when you integrate this, it will then become this complicated thing here. Okay? And everything is in terms of x, not theta.